What's up, everyone? I am back with another video in the lab. It's been a bit since I put out a video, mainly because it's been super busy here. We're building out another lab and I've just got a backlog of work to do. But we've got this Eppendorf 5415D Centrifuge that is starting to act up. I've done a video on one of these before that had a power issue that was relatively straightforward to fix. This guy is exhibiting something different. This is a different unit, by the way, not the same one. And it is giving us this error 3, which, in the manual it says something about rotational position is there's an issue there. We can look at the actual description, but as with most cases, not much to go off of. I don't have a service manual for this, just the user manual. Now, I've been dealing with this issue for a bit intermittently, and I've already checked a couple things. I did verify that the tachometer is working, the Hall sensor that acts as the tachometer for this guy. We can go into a bit more detail on how these work. So it doesn't appear to be something like that. It could be something really stupid or something more complex. So why don't we bring this thing into the repair space and take a closer look. All right, so here we are in the repair shop, and we've got the unit out. We've got it hooked up to an isolation transformer. It is on right now, and we're gonna just see if we can find what the cause of this error 3 is. And if we go to the manual again, it's not very helpful. There it is, right up there. Error in rotational speed measurement system, and of course they give you this: leave the centrifuge switched on, wait 5 minutes. Yeah, so not much help. Errors in rotational speed measurement system. So that would be, at least one would think, the tachometer, which is right there, that black wire harness that connects that 3-wire connector, and it's just a Hall sensor. There's a magnet at the bottom of the motor shaft, and as that thing spins, the Hall sensor will pick up that magnetic field and it'll generate a pulse, which then moves on. You can see there's a bit of isolation here, and so you can kind of see that signal. It traces to this optocoupler here, which then moves on to the digital circuitry, so that you can get to the microcontroller, which also has this EEPROM as well, E squared PROM. Yeah, so that is what I'd be interested in looking at, making sure that signal's getting there. And of course, I actually did fire this thing up, and now it's working. So I will try to replicate the issue, but we'll see. Now, I can go over the topology of this board a little bit. I've done this before in another video, but we can just do it real quick. So here's your AC input. You've got your EMI filtering, right here with these chokes and capacitors, these Y and X class capacitors. There's your bridge rectifier, that black component there, and then that is a current limiter right there, and then you've got this main filter cap. And what's interesting about these, which is a bit, I not so much interesting, because it just, these are kind of old, so it's kind of, from like 2000, some of them, and I was a bit surprised to see a power factor correction IC. All right, so obviously with this thing having a motor, it's going to be generating a power factor less than 1 due to that inductive load, and so that's going to bring the power factor closer to 1. And you would think this is at mains voltage. we would be seeing 165 volts, 160, 170 maybe. I actually have this on the bus voltage, and that's at 195, so it is boosting it a little bit. And another thing that we can check is I can show you guys the gate output to the boost converter. So if you watch the scope, there it is. So that's the gate the signal being sent to the gate of the boost MOSFET, which you can't see on this board because underneath you could see that metal piece which connects via these four sockets there. That is where the three-phase inverter is. So you've got your 6 transistors underneath there in this membrane type circuit board, and then also the boost MOSFET is there as well. And then this is the the resonator for the boost converter. All right, so yeah, it is boosting it a little bit, but anyway, that is that, and that will provide the the bus voltage for the motor. Let's see here. Anyway, this moves on to the power supply for the unit. You've got this UC 2844AD, which is just a a current mode PWM. You've got the switching MOSFET there, and you've got this flyback transformer. And this flyback transformer has what appears to be 2 secondary windings. So you've got 5 volts going, well, not 5 volts, but the output, the input going to this 7805, outputting 5 volts for the digital circuitry, and then you've got another 5 volt regulator here, which is then providing voltage to the main the display board, which is right there. All right. Here is your brake brake chopper circuit. So you've got this MOSFET here that's going to be it's going to be switched on and off to slow the motor down. So it's basically going to be sending that 200 volts to ground as when the MOSFET is on. And that is your chopper circuitry here. You've got some comparators and whatnot. And that's basically everything on this board. Now, so let's do this. Let's probe that optocoupler, the output, and see what we get when we power this thing on. Let's see if we can replicate the signal, or at least turn the motor on, I should say. Yeah, there it goes. Just trigger on it. Oh. Yeah, so we were measuring the gate to the MOSFET, which obviously it's switching much faster, roughly 40, 80 kilohertz, and here we're at 2.2 kilohertz, which if you multiply by 60 for RPM, that's roughly what we're spinning at, 13,200 RPM, right? So, yeah, I mean, the signal is at least being transferred over the, the output of the optocoupler. And I guess we could follow the signal, make sure it's going wherever it's supposed to go. It obviously is during this run because it's the rotor spinning. Yeah. So that's interesting. You can stop it now. You can see that pulse getting wider. Yep, and it's working. It's working again, right? So, yeah. Interesting. Alright, y'all, so I've been looking at this circuit a little bit more closely, and we're just going to walk you through what's going on here. So this is the optocoupler that we've been probing at to get that tack signal. Pin 5, that's the collector. This connects to this hex inverter Schmitt trigger, connects to pin 5 here, which is the third Schmitt trigger. There's 6 in this unit. That then, the input is pin 5, the output is pin 6. The output then connects to this little SOT23-5 IC, which just has C8 on it. I couldn't find anything on it, but I'm pretty confident it is some kind of logic gate. So that connects to pin 1, and then pin 2, if we follow it, you know, you can kind of see it goes underneath this like 47K resistor, and then we keep going, and it goes to the output of pin 4, or I should say this goes to the logic gate, and the input 4A connects to this resistor, this RC circuit, which is interesting. I don't know what the purpose of that is. Maybe to get a cleaner signal, to clean up the pulses, because then this output of pin 4 of this logic gate then goes on to the microcontroller over yonder. All right, and I can show you guys, I can probe each of those things. So yeah, that's how this thing works, or at least the signal gets possibly smoothed out and then makes its way to the microcontroller. Alright, let's probe some of these signals. Let's start the thing up. Still has yet to throw the fault, and I'm starting to get an inkling as to why, but I'll share my thoughts after. Just a hunch. But alright, let's probe the output to let's probe the output to the optocoupler, the collector, first, and we're going to start it up. Okay, so you can see that. We've seen that signal before. Right. So that's also going to the input to the Schmitt trigger, hex inverter. Okay. And this signal is technically inverted. If we had to probe both, and maybe we could see that. But yeah. So that's that. And then that goes on to that signal, that SOT 23-5 logic gate. Alright, now let's look at the input from this RC circuit, okay, which is being fed from the output of that the signal we just measured. So that this passes through this signal. This signal passes through a 47K resistor, and look, that's what we get. All right. This is sent to the Schmitt trigger again, inverted, and we get this signal. And then the output to this logic gate is this signal here. Okay? So, doesn't seem like there's an issue with the rotational positioning measurement system as this error would suggest. The error also never happens while the unit is running, which is why I'm starting to think, and then there's another piece of information. Watch as this thing slows down. Yeah, so the error is never thrown when it's running. Okay. And zoom out here a little. It only happens when the unit tries to start up. And that's when this thing is going to be needing the most torque to get this thing moving. I'm going to shut this guy off. And can't really hear it, but this guy was sounding a little bit squeaky. It doesn't always sound too hot when it's running. It might be that this motor is the problem. And because it can't be driven on startup, it's not reaching, the hall sensor's not picking up that next move. The unit thinks it's a rotational, a tachometer issue. So I have a spare motor for this guy that, you know, salvaged, used. I have so much junk here. This is why I keep it. And I think I'm going to pop that in and see if that works. These things are fairly easy to remove. Okay. You know, you just got to remove these vibration isolators. Just one nut for each one, and then remove the power cable and then the ground connection, and that's it. That's all there is to it. Pretty easy to remove. We're going to give that a try now. Oh, and the other thing I forgot to mention, notice how the other thing that's missing is that the rotor isn't installed, and that's another thing that I was getting at. That rotor obviously is going to require more force to start the motor up. And so that's another indication to me that maybe this is due to the motor just being, you know, a bad bearing, something that's making this guy not start. So yeah, that's what I'm going to do, and we'll see if it works. Alright, so I've got my spare motor here, and one thing I did notice is that this white piece here is cracked. And now the magnet is actually underneath this white piece. This is not the magnet. I guess this is more of like a washer or something, but could that be what's contributing to it? I don't think so. I really think that this is related to the you know, the motor itself, but who knows? I'm not 100% sure. All right, so we've got the new motor installed, but check this out. I thought this was kind of funny. Watch what happens when we start. Watch the display when we start the motor up. You see how the display just sort of shook back and forth? That's not from the vibration of the motor. I think that's from the magnetic field that is being generated by you know, that it's in the motor having an effect on the CRT, which yeah, it just did it again. Wow, interesting. But anyway, so we've got our new motor installed. I think the next test is going to be let's hook up the rotor to it and see if it causes us any issues. All right, got the rotor installed. I don't recommend doing this outside the enclosure, but you know, we're professionals, so let's start it up. It's on tight. Yep, Yeah, so there you have it. Now, there is one more thing I did want to show you. So when I first connected the motor up, I accidentally put the cable in the tach wiring harness in backwards. Now, I didn't do any damage, but what I noticed is that with this motor, now it's going to throw an error 3, but with this motor installed, it tries to spin, gets up to a pretty good speed before it throws that error, which it's doing right now. The other unit, the other motor, it would not do that. It would not get up to nearly that amount of speed if it would spin at all, which is also kind of is confirming that hypothesis that this is not due to the driving circuitry, the tachometer. This is due to the motor being locked up, or just, you know, it's got a bad bearing. So that's really, I think we're in the clear now, which is nice, because this guy the end user really needs this guy. We're quickly expanding. Trying not to get shocked here while I plug this back in, which is something I would do. So it's good that I think we got this figured out. I mean, look at this. Look at all the crud that gets on these, and that's because these aren't. There's not a very good seal between the chamber and the motor, and so, you know, if you're not careful, you're not. I don't know. You don't balance it right. You know, tube flies out, something, and you're not cleaning it. All that is the motor is susceptible to all of that, and in fact, I've got one I'll show you guys just to close out, that is totally locked up, completely. You know, another motor that's completely locked up. So that does happen with these, and you know, you just got to be careful. They get very dirty, and you got to routinely clean them. So yeah. Let's reassemble this guy, and we'll give it a final test. And only time will tell if this solves it completely. But I think we're good here. All right. Just a quick note as I'm putting this thing back together. These clips love to break. I've got one right there, and it's a shame because if they are not clipped in, this thing starts vibrating around. It'll start throwing random errors. It loves to throw error 6 when this thing is loose. So, you know, just be careful with that. I mean, I'm actually I've been meaning to to source some replacement cables, you know, because I have a couple of these that are just broke. And, but yeah, just be mindful of that. Yeah, and see, this is what I'm talking about. I mean, you can see how easily this is exposed. There's no rubber boot that you know. Usually, you'll see with centrifuges where they make a tight seal with the rotor shaft. So, yeah, that definitely exposes the motor to, you know, whatever you're running. If you're running caustic stuff or corrosive stuff, then that's going to cause problems. Even just biologic material, and you be surprised how quickly biologic material can get built up in these. I would definitely recommend taking the rotor out every couple months, giving it a cleaning the rotor, you know, because these things can last a long time if you take care of them. You know, we've got some that are pushing over 20 years old. All right, so all right, there it is, still working, back in its habitat. It's breaking good. Yep, and I even loaded it up, just a mill of water and about 12 tubes, just to see if it could, you know, see if we could trigger the error again, and looks like we're good. I think that was the problem. I think it was that motor, bearing, contaminants getting in there from runs not being cleaned, spill perhaps, who knows. It's unfortunate because I'm out of good spare motors for these. That's the last one I have. Maybe I can, clean up those other ones, take them apart. I've never disassembled one of them. They've got some strange locking nuts on the sides. I don't have the correct drives to remove them. I'll have to look into that, but definitely worth looking into because yeah. Anyway, that's going to be a wrap on this guy. I hope you guys found that interesting. I thought it was pretty neat learning a little bit more about these circuits every time I open one of them up. And you guys have got any feedback, you want to leave it in the comments, please do. And I'll catch you at the next repair. All right.